x. Next, the partial derivative of f of x. Sorry, partial derivative of f with respect to y. F subscript y. F subscript y. Okay, now del f by del y, and this is equal to limit delta y tends to 0, f of x comma y plus delta y minus f of x comma y divided by delta y. This is partial derivative of f with respect to y neighbor. See, we are discuss the definition. Using this definition, we can calculate the partial derivatives of functions. Next, equation when we calculate the partial derivative of f with respect to x, we keep y constant and differentiate the function with respect to x. The partial derivative with respect to y, we differentiate f with respect to y, keeping x constant. Partial derivative. Example 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 to example to example f of x comma y equal to e to the power x sine of xy. See, partial derivative of f, partial derivative of f with respect to x, del f by del x. So you keep y constant and you differentiate with respect to x. So first we differentiate with respect to x, e to the power x, we differentiate in this. X1 is a product will product of two functions of x plus e to the power x sine xy differentiate sine xy differentiate t cos xy xy you differentiate with respect to x, and what do you get? You get y. So this is equal to e to the power x sine xy plus y e to the power x cos xy. This is partial derivative with respect to x. Next, partial derivative with respect to y. This is del f by del x. This is equal to, sorry, del x to del y. This is equal to, you keep x constant and differentiate with respect to y. So e to the power x is this is some function of x. This is a constant. Then you differentiate sine of xy with respect to y, which will give you cos of xy. Then you differentiate xy with respect to y, which will give you x. So the answer is x e to the power x cos of xy. And this is how you calculate the partial derivative of functions of two variables. See example physical example the van der Waals equation for 1 mole of a gas. Van der Waals equation, example number 2. Gulshan nangi microphone do off toro. Example number 2 let us consider 1 mole of van der Waals gas. Van der Waals gas ki 1 mole ki bagi van der Waals equation petarni P equal to RT divided by V minus B minus A divided by V square. In this expression, P is the pressure, T is the temperature of the gas, V is the volume of the gas, R is the gas constant, molar gas constant. A and B are some constants that depends upon the gas. Here we can see that the pressure P has been expressed as a function of temperature and volume. So let us take the partial derivative of P with respect to temperature. So del P by del T at constant volume. Del P by del T at constant volume. So del P by del T at constant volume, we will differentiate this taking V as a constant. So this will give us R divided by V minus V. The second term is the T yaudre. So we consider this as a constant. So the derivative of this with respect to T is 0. So del P by del T at constant volume is simply R divided by V minus V. And del P by del V at constant temperature. Del P, now you differentiate pressure with respect to temperature, with respect to volume, treating temperature as a constant. So differentiate Torani, so RT constant on Lorani. So this will give you minus RT V minus B whole square. And go. Minus 2 minus minus plus Lorani twice A divided by V cube. Equation this equation says how the pressure of a van der Waals gas changes with temperature when we keep the volume constant. And this expression gives us how the pressure of a van der Waals gas changes with volume when we keep the temperature constant. This expression is physical meaning. Del P by del T is R by V minus V. Del P by del V is minus RT by V minus V whole square plus 2A by V cube. So del P by del V is again a function of T and V. So the partial derivative of P with respect to V, it is again a function of temperature and volume. So let us consider next topic. So this take the okay. Let me consider the next example. We just saw that del P by del V have a say, it also depends upon temperature and volume. So in general, the partial derivatives f of x have a say, it can be a function of x and y. And similarly, the partial derivative with respect to y have a say, it can also be a function of x and y. X and y, any function will be a. For example, f of xy equal to y square e to the power x. See this See example f of x partial derivative with respect to x this is del fy del x, and this is equal to y square e to the power x. Now this is again a function of x and y. Similarly, partial derivative with respect to y, this is del f by del y, this is twice y e to the power x, which is again a function of x and y. So the partial derivatives f of x, fx, fy themselves are again functions of x and y. So we can differentiate it again. Amuka differentiate the y. Aduna equation hasna have kari have no. F of x, f of sorry, f subscript x, sorry, partial derivative of f with respect to x. See, I can differentiate this again with respect to x. Amuka differentiate the y. And 60 command in equina, see del 2f by del x square. And this can also be written as f of x. So I have got. So I told del f by del y. So partial derivative say this partial derivative I can differentiate it again with respect to y. So we're going to combine ini del 2f by del y square, or in short f of y. So partial derivative masamak se amuk derivative lo yai hai ko. So these are called second partial derivatives. So these are called second partial derivatives. Partial derivatives. Second partial derivatives of f of x and y. So these are called the second partial derivatives of x. Sorry, of f. Okay. Sige example ama akoy mu yen bu example di yang common noina akoyna sisinaba physics yam common noina sisinaba example am lay. So the example, I have a function v which depends upon x, y, and z. So v is a function of three variables x, y, and z, and this is given by x squared plus y squared plus z squared to the power minus half. Power half na take off, power minus half ni ko. Sigi function j. Sigi v hari function j. We can show that this function satisfies this differential equation. Del 2v by del x square plus del 2vy del y square plus del 2vy del z square equal to 0. We can show that this given function v of x, y, and z satisfies this differential equation. Let us calculate del 2vy del x square. I think you differentiate v with respect to x 2 times. I need to differentiate the y. So let us first differentiate v with respect to x once. 100 differentiate. So the given function is this. This is nothing but 1 by x square plus y square plus z square to the power half Newton. So if I differentiate this with respect to x, what do I get? First, sig square. So, x square plus y square plus z square. Sig half silorni. And sig half silorni. Not because the minus half lorni. Then you take this minus half minus 1. Minus half minus 1 now minus 3 by 2. So this will be 3 by 2 multiplied by, so you break it terms differentiation with respect to x multiplied by twice x. This is minus x divided by x square plus y square plus z square to the power 3 by 2. So this is the first order derivative of v with respect to x. Then a partial derivative of v with respect to x, we are keeping y and z as constants. Constant on Taminiko. Next time, let us differentiate this again. So d2v by dx square. This is equal to del by del x of this object. del v by del x, which is this partial derivative of this. Partial derivative of this what kya hai di? So this is equal to this is equal to CG partial derivative with respect to x. Like x square plus y square plus z square. CG square lordi cube tarni ko. Thangda CG derivative, so minus 1 multiplied by this function x square plus y square plus z square 3 by 2. Adudagi CG minus. You keep this x thamo and you differentiate this denominator. This denominator is differentiation 3 by 2 x square plus y square plus z square to the power half. Can I go? Can I go? So the Makatana simplify Toroga will get the final answer. Final answer final answer to the Karino have del 2v by del x square equal to. So we say that twice x square minus y square minus z square divided by x square plus y square plus z square to the power 5 by 2. See, I'm like, from this term and this term, you take x square plus y square plus z square to the power half common log to the power half common log so the x square plus y square plus z square minus 3 by 2 x term like the minus some minus some okay. Yani cost to the Hiranico. Okay. Under the key next VI. So mind out the we can also calculate d2v by dy square. d2v by dy square. So given function J given function J x square plus y square plus z square to the power minus half x square plus y square plus z square to the power minus half So since the given function is symmetric in x square x, y, and z, the function J x, y, and z is symmetric final expression v d2v by dy square instead of x will have y. Right? So this will be symmetry y is y square minus x square minus z square divided by x square plus y square plus z square to the power 5 by 2. Mind d2v by dz square this will be twice z square minus x square minus y square divided by x square plus y square plus z square to the power 5 by 2. So when I add this 3, sigi 1, 2, 3, they will cancel out and finally you will get 0 as the answer. I leave it as your homework. Come again. What you need to do is you need to add this 3. Takes take sum of this three. d2by dx square plus d2by dy square plus d2by dz square. When you add this three on the right hand side, you'll get the answer 0. So sini sida some idea di aduga akoina sida sagi akoina second partial derivatives of f of x and y have to say akoina d2f by dx square d2f by dy square silai I think fxx fyy lai sinataba atei su laiba sinataba atei su lai adu karino ayo mo bakanda atei du di atei du di karino habda del f by del y lejare na ka you differentiate this with respect to x del f by del y, then you differentiate this partially with respect to x. This will give you del 2f by del x del y. So now first you differentiate with respect to y, then you differentiate with respect to x. So if you f y x this means you differentiate f with respect to y first, and then you differentiate with respect to x. Okay. Del f by del x you can differentiate this with respect to y, and this will give you d2f by dy dx, and this will be written as f of x y. So this is called mixed partial second derivatives. Mixed partial second derivatives. Mixed partial second derivatives. Okay. I'll give you one homework. Homework to the I'll give you a function. Homework say I'll give you a function. This function f of x and y, this is equal to xy square plus e to the power x square y. The function is f of xy equal to xy square plus e to the power x square y. Hariba function zigi f x holo, then f y holo, then f xy holo, and f, this is n, and f of yx holo. And fxx. So now you differentiate this function partially with respect to x 2 times. Segi function z with respect to y anirak differentiate to haiba. First you differentiate with respect to x, then you differentiate with respect to y. First you differentiate with respect to y, then you differentiate with respect to x. What okay. When you calculate these 4 derivatives, you'll find that this value f of xy and f of yx, this value f of xy is equal to f of yx. Sigi function zilloga, when you calculate fxy and fyx, you'll find that fxy is equal to fyx. First you differentiate. First you differentiate with respect to x, then you differentiate with respect to y. Adada phangiba answer to ga. Say the differentiation with respect to y first and differentiation with respect to x next. Sigi say x na hana differentiate toroga y na mu differentiate toba. Sidana y na hana differentiate toroga x na mu differentiate toba. Sigi ani sigi answer is chap mane phangmeba. Habidi kaino the order of differentiation ji x na mu y na mu tawado ni ado x na hana tawgera y na hana tawgera iya di ai answer chap mane haba. X na hana tawga y na mu tawba adagi y na hana tawga x na mu tawba. This will give you the same answer. Adana sigi value ni chap mane tar kaneba. Adu orgadi differentiation ji partial differentiation ji ai x na bu hana tawrasu y na bu hana tawrasu matam chupada managadra. Question sini ko will f of xy equal f of yx always sim matam chupada si managadra. See answer d the answer lies in a theorem. Adu theorem do kai sakra. Okay, let me show you the theorem. So we screen share was screen share was okay, let me show you the theorem. So f of xy ga f of yx ka manai. Say, do you think it is a coincidence? Is it coincidence la? Masi manabam thokra natraga manaroi dabra haba. Sigi anisi manabam thokra sigi anisi manabam thokra natraga manaroi dabra haba. So the answer lies in this theorem. Sigi theorem ju bra. Sigi theorem je ai khasitang chop thola ke. Sigi theorem je khasitang chop thola ke ba. Okay. Sigi. If x and y, so if f of xy and f of yx are continuous at a point AB, then f of xy is equal to f of yx at AB. Otherwise, fxy and fyx may not be equal. Magi meaning kari hai no haragadi. Sigi second order partial derivative animal say. If this second order partial derivatives, if f of fxy, fyx, uneasy continuous whatever at this point B, the value uneasy managa never. Continuous oidrava, the value uneasy manavi, manadavi. Aduna order of differentiation is important or brahadi x na hana differentiate toga y na kona differentiate toga. Haribusiga y na hana differentiate toga x na mu differentiate toga. Uneasy managadra manaroidra hibasi equation kari. Second order partial derivative animal say continuous origati anise managani continuous oidragadi manavai manadabai ko aduna anisi matam chupada managadra haigadi matam chupada managani haibadi leite anisi continuous origati managani continuous oidragadi manaroi haiba yani ko sigi pot chini aduga let me stop.